Okay, so last night I was making shellac, and I was stirring it up with some Elmer's glue in it, and it got all over the end of my stick, you know. Um, and it made like a big bunch of stuff, and I wiped it off into this piece of paper towel, and I let it dry overnight. It was real soft when I woke up this morning still, but it's gotten progressively harder. I've not baked it, okay, but it's now almost 24 hours old, and it's almost hard, like a pebble. And I thought we'd cut it out of there. Let's hang on a sec. Okay, so we got pieces. These guys are just the pieces of paper, um, and they got turned into a little biological plastic wrap around a smallish piece of plastic. And I turn on a light. Okay, and there it is. Look at that. It's like a spit wad with a fancy core. And you can see that it's incorporating the fibers of the paper. This was, cut in right in the middle, so that I could see what it looked like. And there it is. Hey, it was hollow. Look at that. So I didn't roll this or mush it or anything. I just made a little spit wad with my fingers um, to see what it would do and to see how hard it became, because I've got I've got Elmer's glue in there. And that's a 10 by magnification, which is why it's so shaky. And it definitely binds with that paper really well. And what I've found is that rolling it is necessary to get it to meet everything evenly and be homogeneous through its own um, area, unlike this, which has obvious gaps and holes. Um, the paper itself is come on, we can focus. Paper itself is bound to that stuff, and gives it some structural integrity. Um, so they work together real well. And I could bake this, and it would become a very hard spit wad. Um, and you do it when it's still partially moist, before these strands set up. That's an organic crystallization within the lignin and shellac, or the cellulose of the shellac, um, and AuPt. There's AuPt in there. And you can see the little gold and kind of silvery colored things sparkling at you. That's what it is. So, you know, the thing to that I really wanted to find out was whether it'll burn. So, let me find something that I can burn it on, and we'll see. Okay, well, here we go. We're gonna try anyway. Hmm. Okay, so the paper's burning for sure. Is the rest of it? Yeah, probably is. Okay, well, that answers that particular question. Sorta. Maybe. We'll let it burn and see what happens. Burning pretty clean, if you notice. Little bursts of smoke there from the thing going out. But the plastic itself didn't really burn. It was just the paper. And it didn't go through to the other side even. And that's because it has AuPt in it. Now I can take the same stuff and make it with slightly different ingredients, just adding a little baking soda and hydrogen peroxide rather than just water to make my shellac with. The alcohol has water in it, and so I'll use a hydrogen peroxide with it, and it goes in to the shellac. And when the hydrogen peroxide starts reacting with the baking soda, it's in with this Elmer's glue. It makes a gel that will have bubbles of carbon dioxide inside. And I think it won't burn at all. I mean, this did pretty good. It was better than it could have been, considering it was wrapped up in paper. And I don't know if you noticed, but I picked it up right away. It wasn't hot. You know why? It's because of that AuPt. I put in not metallic AuPt, but covalent AuPt. I didn't melt it. I just put the dust in the plastic. And it makes the plastic almost unmeltable or unburnable because it has such a high melting point. The paper burned on the outside, but as soon as it got into the interior here, it just sort of scorched things where the paper was attached and went out. It didn't even smoke because this part wasn't burning. It was just the paper. And the paper has like hemp seed oil all over it and stuff. Can't help it. I've got it all over my hands and all over everything else. I use it for literally everything. It is the most useful thing I have in my house. Hemp seed oil. So anyway, there it is. I think we've got biological plastic that resists flames. And that's pretty far out because, I cut that in half and it's still basically the same two halves, just a little less paper on that one. Whoops. I'm doing this through my phone camera. Hard to judge distance. Okay, anyway, that's what I wanted to show you this time. Biological plastic that doesn't melt and doesn't burn.